Hey, welcome to this lesson where we extend more on proofs. So what is a proof? Let's remind ourselves. A proof, the way we're using it in mathematics, is a noun. It's evidence or argument establishing or helping to establish a fact or the truth of a statement. In this lesson, the essential questions are: what is a formal proof? What is reasoning? What is inductive reasoning? And what is deductive reasoning? By the end of this lesson, you should be able to understand the importance and necessity of geometric proofs. So what is reasoning? Well, reasoning is a noun, and it's the action of thinking about something in a logical, sensible way. So we're going to use facts that lead us from one statement to another so that we can reach a logical conclusion that proves a statement that we're talking about. So think of it kind of like you know a bunch of facts, and you know one thing, and you want to know if this last thing is true. Well, you can't just use that one thing. But if you use other facts that are linked to that first statement and lead to the other statement, you're kind of bridging a gap in your reasoning as to why the statement is true. All right. What is a formal proof? A formal proof or derivation is a finite sequence of sentences called well-formed formulas in the case of a formal language. So don't worry about that part. That's a little confusing. But a formal proof is like I said, statements going from it's a sequence of sentences going from one statement to another that we know are true so that we can reach that final statement to say, yes, this statement is true. Think about trying to prove if someone stole a cookie out of the cookie jar, or try to see if someone stole your pen. You want to start with something logical, like that person was near my desk, and work from there. Instead of just saying that person was near my desk, they stole my pen. That wouldn't be very logical. A lot of different things could have happened. That's called jumping to conclusions. But if you kind of form this proof as to where this person was near my desk, no one else was near my desk, they have the same pen I have, and I don't have my pen anymore, that kind of logically breaks down, and you use reasoning. And so a formal proof is when you write that all out and you have a statement for a reason for each statement you make, and it leads you to proving your final hypothesis, or your example of what you were trying to say. So now you might be thinking, okay, so this is kind of confusing. What exactly is logic? Well, one thing that makes geometry better than any other math class is you actually get two classes in one. You're going to learn about all the angles and triangles and stuff, and that's probably stuff you expected. But you also get an introduction to what we call logic. Logic is really just a systematic way of thinking. Most people don't actually think logically. Like I said, a lot of people jump to conclusions, or they use their emotions and then back their emotion decisions with a set of selected facts, instead of looking at the facts and coming to a conclusion logically. So to use logic, you're using facts to determine the way you think or the way you act, instead of using emotions and then trying to use facts to back those emotions up. For example, think of it this way. You see a brand new pair of shoes, and you really, really like them. Your emotions are high. You want those shoes, so you buy them. And at the end, when you're done buying them, you say, okay, I deserve these shoes. I worked hard this week. I earned a lot of money. I deserve to treat myself. Those are all facts that are trying to reason or rationalize why you bought the shoes. You bought the shoes because you wanted them. Your emotions were high and you made your decision. Now, if you were thinking logically, the logical explanation would be, okay, do I need those shoes? I have shoes on my feet. I have 5 other pairs of shoes. All these shoes are practically brand new. So your logical conclusion is, no, you don't need those shoes. I'm not saying it's a bad thing to go and treat yourself and buy shoes that you really want. It's just not a logical, you don't need shoes, so it's not logical. That would be an emotional decision. There's two types of reasoning that I want to really talk about, and the first one is deductive reasoning. It's a logical process in which a conclusion is based on the concordance of multiple premises that are generally assumed to be true. Okay, that's a mouthful, right? So pretty much you're making statements. You're starting with one statement and you're making statements from there that are generally assumed to be true. Deductive reasoning is sometimes referred to as top-down, because if you think about a list, you start with a one statement and then you work your way down. Deductive reasoning is top-down because you work your way down. And its counterpart is inductive reasoning, which is sometimes referred to as bottom-up logic. So deductive reasoning, you start with a bunch of facts. You use those facts to find out or prove another statement. So to sum that last one up, which was confusing, it's deductive reasoning is to conclude something is true based on facts, definitions, and axioms. Okay, you know something, usually a small fact, and conclude some specific thing happened, like Sherlock Holmes, or any other detective. You know some facts about human nature and science, and you look at a crime scene and find other things, and from there you use those facts and you logically deduct to a conclusion where you can identify what happened and who did it. Another example, your little brother has chocolate sauce on his face. You conclude he must have eaten chocolate sauce. Now that's a little vague, but it's an example. You see a fact and then you make a conclusion. So deductive reasoning, you see a fact or multiple facts and you make a conclusion. Example number 2, you know that all triangles add to 180 degrees. That means that the specific triangles you are working with adds to 180 degrees. So you know a fact, you make a conclusion. Inductive reasoning is a little bit different. It's reasoning in which the premises seek to supply strong evidence for the truth of a conclusion. So instead of starting with the facts, you say, this is my conclusion, and this is why it's true. So inductive reasoning is to conclude a general fact based on specific examples. All right. So you let go of an apple and it falls on the floor. You do this 10 times, and then like our friend Isaac Newton, conclude that every time you let go of an apple, it will fall down. So you kick your cat, and every time you do, it scratches you. You conclude that if you kick your cat, you will get scratched. So this is more of an experimental kind of reasoning, where a bunch of things are happening, and they all seem to have the same outcome. And therefore, you conclude a fact. So you see this a lot in science. You hear like a scientific experiment. In order to prove theories, scientists will go and they will do the same experiments over and over and over. And if they seem, for thousands and thousands of experiments, to seem to get the same outcome, they come to a conclusion or a theory that says, yes, this is true when this happens. So another example, you add up the interior angles of 100 triangles, and every time you get a sum of 180 degrees. After your hand cramps, and you conclude that all triangles must have an interior angle sum of 180 degrees. The difference is subtle. Again, deductive starts with general facts and reaches a specific conclusion. Inductive starts with specific examples and concludes a fact. That's all for this lesson. I hope you learned a lot. If you didn't, if you're confused about something, please go back, watch through the video again, and don't hesitate to reach out to us if you're still confused. Come to the Math Cafe, give us a phone call, shoot us an email. We'd love to help you. In the next lesson, we're going to talk more about theorems and get more in depth about certain types of theorems and different parts of theorems.